Hello everyone, welcome back to lesson number 23, where we're still talking about Maclaurin and Taylor series. We're going to do two more examples using Taylor series for cosine of x, just two more different types that you haven't seen before. And then in our next video, I promise we're going to do 1 over 1 minus x. I keep saying that in every video and I keep lying, but I checked and it's going to be the next one. So let's look at an example of how to rewrite a Maclaurin series for x cosine of x. So this is very similar to the example we just did for cosine of 2x, where we had to replace x with 2x. So here's all you do. You first of all want to write out what the Maclaurin series is for cosine of x. And so remember that cosine, again, is an even function. So we're going to go ahead and write the 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And it's just enough to write a couple of these out just so we're okay with what's going on. So I write out a couple of them just so we get the idea of this. And let's just add one more just for our good thing here. So we have 0, 2, 4, 6, 8, and we alternate our signs. Well, this is cosine of x. It should be no surprise that if I want to do x times cosine of x, then all I'm going to do is I'm going to, and then this is going to be weird, I'm going to multiply all of these terms by x. Right? I'm multiply these by terms. So I'm just going to distribute the x to it. So x cosine of x is going to be x minus x cubed over 2 factorial plus x to the 5th over 4 factorial. I don't know why I'm getting ready to write 5. So x to the 5th over 4 factorial. That should be plus as well, my lord. Minus x to the 7th over 6 factorial plus x to the 9th over 8 factorial. So whenever you guys see something, because again, eventually we're going to learn to start rewriting these and figuring out what the actual series is, that's always a helpful thing to see that all of our exponents are odd, all of our factorials are even, so I can undistribute an x, and that's going to tell me that I'm back to a cosine times a variable x. So that's all you do. So if this had been an x squared, you would have distributed an x squared to all of them, and this would have been x squared to the 4th, to the 6th, to the 8th, to the 10th. And that's really all that you have to do. If this had been, cosine of x over x, we would divide everything by x. So it would be 1 over x. This would be x, x cubed, x to the 5th, x to the 7th. And that's all that you got to do, all right, for this particular question. So let's move on to this next question. It says find the Taylor polynomial for degree n equals 2 for this function where c is equal to pi. Now, this one is going to be a little bit crazy, but we can do this. So I'm asking for a Taylor polynomial degree of n equals 2. So I want my degree to be 2. So we're going to first of all figure out what cosine, or what f of pi is. So we're going to go ahead and plug in pi. We're going to get pi times the cosine of pi. So that's the first part of our Taylor series. Is remember, it's f of c. So plug it in c, we get pi cosine of pi. Well, cosine of pi is -1, so we're going to get negative pi. So that's going to be our very first term. So I'm going to go ahead and down here, I'm going to write down negative pi. Now the next thing we need to do is we have to find the derivative. We have to find what f primacy is. Well, we got to figure out what the derivative is first. Well, yes, we have to use the product rule. Right? We have to use the product rule here. So we're going to do the first times the derivative of the second plus the second times the derivative of the first. And so we're going to plug in pi to this. So we get pi times negative sine of pi plus cosine of pi. And this is the value that we're going to be using, right? So when we do this, we're going to get that this is going to be, well, sine of pi is 0. So this whole thing is going to be 0 plus the cosine of pi is going to be -1. So we're going to get -1. So f prime of c, f prime of pi is going to be -1. So it's going to be -1. It's going to be x minus c. Now again, this was all first derivatives. So this would be to the first all over 1 factorial. And then we have to take the second derivative. And so really quickly, I'm going to rewrite this as negative x sine x plus cosine of x. So we have to use the product rule again here. And so it's going to be negative x times the derivative of sine of x, which is going to be cosine of x, plus sine x times the derivative of negative x is negative 1, plus the derivative of cosine, which is going to be negative sine x. And, you know, we're really just looking for the value, and we're not having to take another a derivative because we're only looking where n equals 2. So this, again, a degree of 2. So we have a degree of 1 here. So our next term is going to be 2. So I can go ahead and just say that if I plug in pi, this is going to go away, and this is going to go away. So what am I left with? I'm left with negative pi times the cosine of pi. Well, the cosine of pi is negative 1, so negative pi times negative 1 is just simply pi. So our last term is going to be plus our f double prime of c is pi, and then it's going to be x minus pi squared all over 2 factorial. And so this is going to be our answer. And that is what we're going to say. You guys have now seen right now a good amount of examples for Maclaurin and Taylor series polynomials for sine and cosine. So this was a very short video, which is totally fine. I'm going to now move on to 1 over 1 minus x, and we'll do that one in the next video. So I'll see you guys then.